Welcome back on the channel, guy. I'm sorry for the time, but I will do my best to upload a video like each week from now. So today I want to talk about the compilation. Basically, the compilation in the C language, the compilation is the step that will allow us to change this text, because this is a text, as you can see. Change this text into a binary code that the computer can execute. So this is the compilation, and it's done by a program named GCC. So it's a compiler. The compiler is the program that will change this text into let's say a binary code that our computer can understand, and it's done into like three phases. Um, like there is the first one is let's say pre-processor. The second phase will be machine language, compilation into machine language. The third phase will be like compilation into an object file, let's say like this. And the next one will be the linker. So let's see that. Let me show you how to do the compilation. First, let's see what as the last time. I hope you remember. So we have the output of our program, but actually we will do that into the commands, into the console. So to see if you have the GCC compiler, you just have to put there like GCC dash dash and version. So I can see that I have GCC. I do have GCC. If you don't have it, you have to go like on Google and try to download it on your platform. So let me do the preprocessor step of the compilation. To do that, I will use GCC with the option, the parameter dash e, a capital E, and 10. I specify the output. So I specify there like the output will be name hello.i. So let me list my directory. I can see that I have a new file, and let's see into what is in this file. So I will open it here on JNE. I will open it. Okay. So you can see there, here it is, like after the first step of the compilation. This is what we get after the preprocessor phase of the compilation. Basically, the preprocessor is doing like let's say a text transformation, because he just changed the text and nothing else. He add all these things. So basically you just go, and because those are like preprocessor directive. For example, if I put here like sharp define, I put this and I put like name, and I will put a string like this string or script, and let me use my function print here, and I will specify the name is, let's say the name is just a basic use of this function, and 10 I put there, I put name. So you will see first this is like it will show that to this function that I want to use something else there. So the function will look into the other parameter that I give to the function, and it will try to put the parameter. So here is name, and it will put the value of name where I put this thing. So they are specified that it is a string. So let's try to execute it. So and you can see that the output here, it is my name. Okay, so and we'll do it again. So let's do again preprocessor step. So I will do that just to, I want to show you something actually. Okay, I can just go back there and you can see that my file have changed. So change it and you can see that here my name is there, but in this file I haven't put my the value, because the preprocessor will look into this directive. So when he will see that, he will check into my source code, and any place that he will find this variable name, it will change it with this string value. And what the preprocessor will do, it will also remove like all the commentary, because those are commentary. So they are, it's a text that will not be executed in our program. Sorry. So this is what the preprocessor is doing in the compilation. Let's look into the next step. And the next step is compilation into a machine language. So a machine language, those are language that are, they are set of instructions that have been made for a specific computer, a specific processor or architecture. Let's say it like this. So it's a programming language that the machine can understand like easily, because it was made for a specific machine. Okay, so let me show you how to do that. So I will use my program GCC again, but this time I'll use the parameter -s, and I put my file. I will use this file that I just made, and then I can see that I have another file with the extension .s. I will look what is into this file, and you can see here we have our machine language. So those are instructions that are sent directly to our processor, and you can see that I think is each architecture have its own machine language. I'm not sure. I have to look into this. So for the second step is just that. If you want to know what the machine language look like, you have it there. So let's go into the next step. The next step will change my file into an object file, like a binary file actually. So let's do that. To do that, I will use GCC again, but with the option is -c, a smaller c for this time, and I put the last file I obtained, but it doesn't matter. I can put -c, and you see there I have another file. But even if I put like this, I use the previous file. The previous file is the same thing. So let's look into this. You can see there, if I try to open it, nothing, because actually Shani can't open it, but I can try to read like in a text format from my console here. So let me try to read it, my object file, and you can see that is something that we can't actually read. So to read it, I have to use like another program like xtemp, and I will try to read it just to show you what it looks like. So this is an object file, a binary file that the computer can understand. those are instructions that the computer can actually execute. So now let's look into the next file. Yeah, the next step story. The next step is the linker. What the linker will do? The linker, because sometimes you have many source program, and you have to link all these the object file, because you have many source program. It means that you will have like you will also have many object files, and you will have to link all these files together to make the final executable. And also like the, the linker will go and check to like this library of standard input and output. It will go and take the binary of those library and include it and link all this library with your main project to make your final executable. Let me show you, and to show you that I will add an instruction here. I will add this instruction like just include. I will add like welcome. Let's say welcome the hash, and I will create this file welcome.hash. Actually, you don't need to understand it actually, because these are concepts that you don't need actually to understand the advanced concept of the C programming language. But just to show you the linker files, I will show you that. So let me say that if in depth like let me just say yes, define okay. So I will put welcome. Here I'm just creating a smaller function. I'm just declaring the function actually. Then I will implement the function in this other file that I will call welcome.c. So this is another source file. So, and again I have to put like the standard library. I put it again std.ish. Then I can implement my function. Actually my function is welcome. Okay, so I can implement this. I will just put like again printf again. We will use this function. We will use that. So welcome, and that's it. I save it. Now I save it also. Now I have already included this file, so I can use this function there like directly, cause and I can save and I will try to execute. Okay. I don't know what is don't work. I think I have to configure this IDE. I don't know if you have code block or another IDE. Maybe it can work, cause I don't know. I think this IDE needs some configuration, but I can do that actually. I don't need the IDE to do that. I can do that like here. So I have how many source program do I have? I have 3. I have hello.c and presentation.c. So this is the 2 files that of my program. It's not presentation, it's welcome.c. Sorry, welcome.c and hello.c. So let me make the compilation. First I will try to do that again. No, let's go like directly. So the final files of the compilation. First I will make some object file with hello.c, and you can see that. So I made this file, this object file, and I will make also an object file of welcome.c. I will make it cc.welcome.c. What's happened here? first development. Hey, yes, I have to put this option dash C. If I don't put it, it will not work because I specify that I want an object file because actually GCC have tried to make it a program by its own, but it can't. So here you can see I have another object file, welcome that one, and now the linker, it will link these two files together to make my final program. And to do that, I will put like my first object file and my second here, and I can put dash o. Oh, sorry guy, my English isn't that. So I will just to specify the name, and I put here. So I say I want my executable, my final executable file to be named hello. So let's put, and now I can execute it. You see that? Because actually this is my function. My function welcome have been called like successfully. The name is, and as you can see, so the last phase of the compilation have linked this file hello C and welcome C, not actually this file but the object file. So it was like hello.o and welcome.o, but also the linker will go and take a, like if you have included another library like stdio that is, it will go and check for the binary of those library and include it actually into your final executable. So I think we have said like not everything about the compilation, but I think we have covered a big part of the compilation in the C language. So I told you see you next time. I think I will upload a lot of video are coming I think. So I hope this video will help you, and have a good day. Thank you.